And here's a walk through the key. I know you guys have the key and can read it yourselves, but sometimes it's just the explanation that's kind of unsure where they come from. So I wanted to show you how I approach that back page on the pretest. What if I give you 2 points again and ask you to find a parabola, an ellipse, or a hyperbola? And honestly, the key is in graphing it. You have to put those points on the grid. So the very first thing that I'll do is I'll put in the -1, 4, and I'll put in the -3, 4. And then be careful to label them. I don't have it in this picture, but one's the focus and one's the vertex. And then from there, you can kind of pull all the other pieces together. You have to know what's important. You have to know what the equation looks like. So for a parabola, you're going to have two options. It's either y minus something squared, like you see here, or it's x minus something squared first. And that just depends on what type of equation you're dealing. If you're dealing with a left-right or an up-down parabola. In this case, we're dealing with an up-down parabola. Or I'm sorry, left-right parabola. So here's y minus 4 quantity squared is I chose y squared to be on the left-hand side just by looking at this first 2 points and saying, you know what, if I put a vertex there and a focus on the left of it, this thing opens left and right. So I need y squared and not x squared. And this is a good time to bring up the key too. For whatever reason, and all my infinite carelessness, I managed to put in a squared on the x side of it, which is silly, which I'll go and fix later, but I bet you figured that out. There's no squared on there, but it's just the y squared on the left-hand side. And left to right, gotta have y squared, that's all I'm thinking. The vertex is what goes in for h and k, and so as I go through here, this h and k value, my vertex is -1, 4, and so here's -1 and here's 4 after the minus sign, so x minus a -1 and x minus 4. And the only other thing you need for the parabola equation then is to find out what this p is, and then you've got an equation in standard form. And p, once you have those 2 points, is the distance between the focal point and the vertex. And so there's your distance of, now it's 2, but it's to the left, and you realize it's facing left, so it has to be a -2, and that's what you're seeing down here. So there's the equation. It's pretty quick from 2 points to come up with the equation. If I were to get more detailed and said, hey, I want you to draw a really good sketch of this too, remember the other detail about sketching is that you want to make sure you know it's facing left, and you've got the focal point and the vertex in the right spot, but you want to remember that the distance up and down here, this whole distance here is 4p. So I don't think my drawing here is to scale, because if p is 2, that's a distance of 8. And a distance of 8 would mean, so my 4p is 4 times 2. Remember, it's the absolute value of that 4p. So I'm thinking that's going to be 8, 4 times the distance of 2. So if that's 8 all the way across, I'm thinking 4 up and 4 down, and then you draw your sketch. That you guys did really well on the first page of the pretest, getting the width of that parabola. Just remember, from end to end through the focal point, it's a distance of 4p in absolute values. And then I usually split it in half up and half down from the focal point. Cool, that's just some little details. In the end, the final result is still good. And I'd love to get a different color if I could just get this pinwheel to work. It's not going to work. I'll find another way to get that color to change one of these days. Here we go. But that's the end of that road. So looks like this equation stands, and all is well on the key, at least in that regard. The ellipse equation down below, it's a little bit different. Plotting the ellipse, it's going to be hard to see inside here. If I put the point 12, 0, and then -12, 0 as foci, you'll see them in these two spots here, and I'll try and darken them in a different color. Okay. From there, what you get from putting those 2 points, that is a ticket to knowing what C is. And since 12, 0 and 0, 12, they're both left 12 from 0 and right 12, we're looking at a C of 12. That's like a given from just stating where the foci are located. So if you can find out how far apart your foci are, C is going to be half of that distance. Okay. So after that, then you're given some other information. It says the length of the minor axis is 10. And when you say the minor axis is 10, then you're going to go up 5 and down 5. The only deal is you have to make sure you know where center is. In this particular case, from the 2 foci that I was given, I could tell the center was definitely 0, 0. And so when I'm going up 5 and down 5, that's where you get these points 0, -5, and 0, 5. Okay, so that's B. So there's your B value. And then the only other thing we need now is A. A is going to be out to the major vertex. So we just need to find out how far is it out to this major vertex, and that's going to be our A value. And we'll get that from knowing the Pythagorean relationship that we have in here. So if we take a look at my word, it's all off to the side here. We calculate that a is 13. Okay, so a squared equals b squared plus c squared is the relationship between a, b, and c in an ellipse. And so we'll just go out 13 to the left, 13 to the right. Just make a quick sketch. The equation that goes with it, it's kind of off the screen here, but I'll redraw it here just for fun. When you have an ellipse, you get the x squared and the y squared, like we did in the previous example. But you're trying to figure out where you're going to put a squared and b squared underneath it. You're also doing x minus h, which is the x coordinate of your vertex. So in this case, that's 0, and y minus 0. And when you do that, obviously that's not necessarily necessary to put the y minus 0. You know it's just going to be x squared and y squared, but you're certainly welcome to put it in there if you like. And then you have to decide, all right, a squared is the bigger of the two. And since this one opens left and right in my drawing, then that means my a squared, my 13 squared, is going to go underneath the x squared to open left and right. And then my b squared of 5 squared, that's going to go under the y. And that's the equation. You can leave it with the minus zeros or not. You can leave it 13 squared or 169 or 25. As long as you get the details and can interpret it. That's the big deal. So standard form of an equation is so we can interpret it for other purposes. Cool, and then we'll do the hyperbola next. And so I'll pause this and get another picture going. So here's that picture of the hyperbola problem down on the bottom. And what you get are, in a hyperbola, there's only 2 vertices. And 5, 1, and negative 1, 1. This one's pretty direct. And so I'm going to darken things in as we go along. There's 2 vertices, and what that gives you right out of the chute is that you have access with some thinking and some deduction to what a is, because the distance to those vertices is your a value. So I plotted those 2 points at their locations. What you have to do, though, is you have to find halfway between them, because that's your center. And so if I'm at this is negative 1, 1 on the left, and 5, 1 on the right. That's a distance of 6 between them. So I'm thinking a is 3, but I'm going to plot that point and get my midpoint. So I would go 3 over. So I'm seeing 2, 1 as my midpoint, halfway between. Okay, and so that's just some deduction. Do it with a graph. I wouldn't experiment any other way, or you're going to end up in trouble. So those pieces of deducing where that midpoint is just finding out what A is, got to know where the middle is, and it's just a deductive process. And if you use the graph and think carefully, you'll be just fine. Next thing is I'm also given foci of 6, 1, and 2, negative 2, 1. So I'll put a little different description here. I'm going to put let's go red on those. Okay, foci are going to be red. Glowing red. All right, I plotted the 2 points as given, so there they are. Then that's going to give me C. So C is 4. The distance from my new found midpoint is 4 in each direction to get to those foci. Now that we have A and C, we can find B deductively. And remember, the equation for hyperbola it looks like our classic Pythagorean theorem. So you're going to get C squared equals A squared plus B squared. Work it out and get your B as the square root of 7. The distance B, remember, kind of takes you out into space. It's just to create that rectangle to make a nice sketch of our graphs. And I didn't put it in here yet, but I thought I'd do it. There's B up and B down. And what happens is that you just make that rectangle that goes with it. And then from that rectangle, we do diagonals out of those corners. And then your hyperbola just snuggles up against those asymptotes. Okay. Now, finding the equation of those particular asymptotes, I gave you guys a help sheet today to look at in class that'll give you a sense of how to come up with that, but I have a feeling you'll be just fine nailing those down. So take a look at that sheet and deduce the best you can. Back to the equation, you guys have a vertex, or your center that we located of 2, 1. And so when we're doing the hyperbola, you have to be careful. The 2 and 1 are going to go with x minus 2 and y minus 1 respectively. But whether you put x squared or y squared first does make a difference. And it depends on which way your hyperbola opens. And this particular one opens left and right. And so you want x squared to go first. And a squared is going to go underneath that. It'll go under the axis parallel to which it opens. So a squared is always first in a hyperbola. It's always biggest in an ellipse. So here it is. My a squared is 3 squared. My b squared, the square root of 7 squared, will just be 7. But those are the 2 denominators in their respective order. And order matters in a hyperbola. You've got to have If it opens left and right, x squared is first with a squared underneath. If it opens up and down, y squared will go first with a squared underneath it. Okay, so that's the equation. That's the graph of it, a rough graph of it. And that's a pretty good comprehensive review. You guys are ready.